Hi everyone, great to see you back at foxlearn. In today's video, we're going to take the CRUD app we built in the last video using ASP.NET Core MVC and refactor it using clean architecture. Why is that? Well, as your app gets bigger, things can quickly get messy and tough to keep track of. Clean architecture helps us keep everything organized, so it's easier to scale, test, and maintain over time. Quick recap. In the last video, we built a basic CRUD app to manage students. It worked well for a small project, but once you add more features like authentication, APIs, file uploads, etc., that tightly coupled structure becomes a problem. So today we'll break our project into 4 layers following clean architecture principles. Clean architecture separates your app into layers, where each layer has a single responsibility and only depends on the layers below it. Here's a quick overview of the 4 layers. First, create a folder named domain, and then move the entities folder inside it. This is the heart of your application. It contains entities and interfaces, nothing specific to ASP.NET Core, EF Core, or any framework. Just pure business logic. So this layer defines what your app does, but not how it does it. Next, go ahead and create a folder called Application. This layer contains use cases, the logic that orchestrates operations. Here, we define service interfaces and their implementations. The services call the repository, which is defined in the domain layer. It doesn't matter if your data comes from EF Core, MongoDB, or a third-party API. This layer stays the same because it only depends on the repository interface. Now, create a folder named Infrastructure. This is the infrastructure layer. where we implement the iStudent repository interface using EF Core and connect it to a SQL Server database. Think of the infrastructure layer as the one doing the dirty work, saving data, talking to external APIs, etc. Here's how we'll organize our solution into separate projects. And then we'll connect everything using dependency injection in program.cs. When we use dependency injection in ASP.NET Core, we need to tell the system how long a service should live. And that's where add scoped, add singleton, and add transient come in. So what does add scoped mean? Add scoped means a new instance of the service is created for each HTTP request. That instance is shared within the same request, so if multiple components need it during that request, they all get the same instance. Add singleton creates one shared instance that's used throughout the entire lifetime of the application. On the other hand, add transient creates a new instance every time it's needed, even within the same request. Finally, the presentation layer. This is your actual MVC project with controllers and views. In the presentation layer, we'll stick with the default ASP.NET Core MVC structure, using the controllers, views, and models folders. This layer handles all the user interface logic and talks to the application layer through services. There's no need to create a separate folder for the presentation layer. This entire project is the presentation layer. Here's our students controller, which handles all the HTTP requests related to managing students. Notice how we inject iStudent service through the constructor. This is a key part of clean architecture. Instead of calling the application DB context directly here to interact with the database, we rely on this service interface. This way, the controller only focuses on handling web requests and responses, while the service layer handles the business logic and data access. For example, the index action calls _service.gets_hallmark_async to get all students, and the details action fetches a single student by ID. When creating or editing students, the controller receives data via student view model, maps it to the domain student entity, and calls the service to save the changes. Finally, the delete action also uses the service to remove a student. By using the service interface, we make our controller simpler, more testable, and less dependent on the database implementation. So what's the point of all this separation? Your business logic is completely independent of EF Core or MVC. You can unit test your application layer without a database. It's easier to replace technologies later. For example, switching from SQL Server to MongoDB would only affect the infrastructure layer. And it just makes your code easier to maintain. So that's how we refactor a basic CRUD app into clean architecture using ASP.NET Core MVC. In a future video, we'll explore how to implement the same clean architecture using Mediator. This will help us apply the CQRS pattern and separate our application logic even more clearly. Now, comment out the string length attribute in the student class. Then, move that configuration to the application DB context by overriding the onModelCreating method. Use .hasMaxLength to define the column length. If you found this helpful, please like, subscribe, and hit the bell to get notified about future videos. Thanks for watching, and I'll see you in the next one.